In this video, we are going to see how to find the middle element of a given linked list and print that element. So, as you can see, we have a linked list with 6 elements, and one can say that these are the middle elements, because since we have even number of elements here, this exactly divides. There is no element exactly in the middle. If we had 5 elements, till 5 only, then 3 would be the middle element. So both of these are valid middle elements. So in this case it should print 3 or 4 as per our definition, and if it's odd, if it was 1 to 5, then it should have printed 3. So let's see how we can do that. So we had seen how to find a loop in a linked list. There we had used 2 pointers, one fast which was advancing by 2 steps in every iteration, and there was a slow pointer which was iterating advancing by 1 step. So we will use some similar concept here. So let's initialize 2 pointers, one fast and one slow, and we will assume that the list has no loops. So this is our assumption. So after next step, slow will be here and fast will be here. Then in the next step, fast will be here and slow will be here. Then fast will become null. Sorry, in second step slow will be here, and then finally slow will come here when fast becomes null. So it will print 4. So it's very simple. On the other hand, if we had odd number of elements, then let's say slow is here and fast, both are initialized to head pointer. After one step, fast will come here and slow will come here. In the next step, slow will come to 3 and fast will come to 5. And now our condition is that we make fast is equal to fast next next. So we end the loop whenever here fast dot next should exist. Otherwise, if this does not exist, then there is no point in calling its next, because this itself does not exist. So our condition will be that the next of fast pointer should exist, and also the slow pointer will definitely exist because fast is always moving ahead of that. So fast should exist and its next should exist. Then only we can find next. We cannot find next of a null node. So fast dot next should be a valid pointer. So here we see that fast has reached to the end and there is no next node. So we will stop here. So again, whatever slow pointer is pointing to, we will print that. Similarly, for this case also we had printed this 4. So here output would be 4 and here output would be 3. So let's write a quick code for that. So we will initialize 2 pointers, both are pointing to head. And the condition should be that fast node is valid and fast next is also valid, because we will do fast next next. and slow will advance by one step. And when this breaks out of loop, we know that fast has reached to the end of the list. So we will print whatever slow pointer is pointing to. Now let's run this code. Let's comment out these things. So let's first print the list to see how long is our list. So our list has 6 elements. So it will print the fourth element, that is 2. So here it has printed 2. Now let's get rid of last element so that we have an odd length list. So let's get rid of 50, or 3 is the last element, so or get rid of 50 itself. So it will be 10, 20, 1, 2 and 3. And now it should, so now it prints 1 because 1 is in the middle, 2 elements are to the left of it, 2 elements are to the right of it. So this was a pretty small problem and one of the simplest. So this is how we can print the middle of the list. This concept of slow and fast pointers will be very handy, and you can use it in multiple problems, and it's a very nice concept. So thanks for watching and give your valuable feedbacks.